The volcano is one of the most powerful representations of nature. It can change territories and the history of humankind. Knowing its behaviour during an eruption is essential in order to understand its evolution. I'm standing on the edge of the Vesuvius volcano, close to Naples, where the Kronos project is hoping to uncover the mechanics behind an eruption.
The Bay of Naples is potentially one of the most dangerous areas in the world. The densely inhabited city lies in the middle of a volcanic system made up of the Phlegon Fields, the island of Ischia and Vesuvius. It's the perfect case study for researchers from the Kronos project who are developing a new model to understand the process and timing of a volcanic eruption.
What
we know less about is the supply system of volcanoes, where magma is formed, the evolution of magmas. To find this out, we would need to use techniques like tomography, using X-rays as we do on humans, and studying the rocks.
The study of rocks is at the heart of this European Union-funded project. Kronos scientists are combining advanced theoretical models and unique laboratory techniques in the hope of unravelling the mysterious timeline ahead of a volcanic eruption.
Why is it so important to study volcanic rocks? What information are you searching for?
A rock is like a broken clock at the scene of a crime. It shows the time of the incident. It's precisely what we want to do with Kronos, to define the timeline that's brought a volcanic system from a state of quiescence to a state of activity.
It's impossible to study the making of an eruption from inside a volcano, so researchers are starting with the volcanic rock and working backwards to its liquid state of magma.
The model we're looking at works like this. When a new, hotter magma arrives in the underground magma chamber, it triggers a mixing process similar to the one we see in a cup of cappuccino, when you mix coffee with milk. The longer you stir the milk and coffee, the better the blend. Thanks to this information, we can read from the rocks how much time has elapsed from the start of this mixing process to the beginning of the eruption.
To do this, the team at the University of Perugia has created the world's first magma mixing machine, which melts and blends samples of volcanic rock. As every volcanic system has a unique subterranean mineral structure in magma, each volcano is left with its own geological fingerprint.
We bring the rock to the melting state, and then we need to characterize the physical properties of the magma, and for that we use a viscometer. That measures viscosity at high temperature.
The mixed magma is then analysed to uncover its new characteristics. Repeating the tests at different stages of the melting process produces a timeline of the chemical changes. The Kronos project has already revealed crucial information about an eruption, as well as the reliability of the model.
What's intrigued us is the time elapsed between the start of the mixing process and the beginning of the eruption is around 20 or 30 minutes. A statistical analysis we've done on 200 powerful eruptions on the planet has shown that this mixing process happens in 99% of cases.
The eruption of a volcano is still an unpredictable phenomenon, but understanding the internal processes of an eruption could help spot warning signs and help mitigate the potential impact of volcanic activity on society.